Hello.
Happy New Year!
So you had a question for me, Helena.
What have you been doing since Christmas Day with your new 3D printer?
That's a good question, and I think some of my readers and viewers have been asking it too. Well, this. If you watched my last video on Christmas Day, and I've done a couple of videos of the printer running, you'll see that I bought a new printer, and the link to the video is actually going to be in the description. And I've been doing lots, I mean so much more than I did with the old printer. So I guess we can first start by looking at what I've done and comparing it with the old printer.
So we got this for our Pyrus robot.
So we've got a set of these gearboxes.
For our Pyrus robot.
Absolutely, and there'll be another video talking all about them, but one of the things this printer let me do, because I started to feel quite a lot of confidence in doing them, and I was waiting to be able to do this, and I was going to try it on the old printer but would never have coped. So I've iterated. I've done many versions of this gearbox, adding features as I kind of went, there's a flaw there, and tried to assemble it and went, I can't get access there. So I was able to go and make many versions of this to get to the gearbox that's actually been mounted. And that was because I could trust this printer, and I've been able to leave it unattended to do 35-minute and even 2-hour prints, which has been exceptional.
Also 3 hours.
Well, yeah, exactly. Okay, so while my new Flashforge is printing something, I thought I'd show you around Flashprint. And Flashprint is the device or the tool I'm using to make prints on the Flashforge. So it doesn't, I believe it doesn't work with Cura. I believe it has its own form of code like G-code, but it's still reasonably simple to use. So if I take something I want to print, and there's either my own designs, this one I'm printing today, and this is, I've pulled in a pegboard caliper holder. So I've got a set of calipers, they're in a box, it'd be nice to fit them on the pegboard. So the first thing is it spotted problems with the model. And a few times when I've gotten, so I've already tried a couple of models from Thingiverse or Umagine, and it'll tell you if you've got a repair or if it's off the platform. So within there, that looks quite nice. So right click to spin around, it's all rendered beautifully. Now, it is currently connected to the printer via USB, but it can be Wi-Fi, but it says down here, status is printing, I've got the extruder, I've got the pimp progress. I can interact with it here as well as with the touch screen. So we've got all the standard controls, so if I highlight the part, we can move it around, or we can, by hold click, you can type a movement, you can center, it's kind of nice. Rotation again, you can drag these controls, you can type it in, so you've got increments of 90, which is kind of nice. Scaling, now I've been doing some things around for Helena. She's doing a space shuttle model, so that needed a certain amount of scaling. We scaled it to 50%, and also inches to millimeter, which is kind of handy. Oh, maximum. There's a nice little typo there. Cut, so if you want to cut a part into multiple pieces and reassemble them, it's built in, so not a bad tool. This particular thing is not going to print without support. I'm going to go and say we've got automatic supports, and I'm going to take them. So there we go, support structures. So we get the tree-like supports. You can go for linear supports. We can. Okay, that's those ones. Those are kind of fairly simple and dull. Oh, and look, see here, the cursor is allowing me to drop extra supports in. Now actually for this, that linear support would be a nightmare to take off, so it actually makes no sense at all, so we'll delete these, all the supports. Now, I thought about lying this flat either way, but it actually generates far more support material to support those surfaces, and hopefully, despite having not looking exactly flat along the bottom, that's still going to be reasonably stable, and I am getting really good bed adhesion to the extent that I'm having to actually use something to hit it with to get things off the bed. So if we click back, now it'll say save the support to the file, and okay, there we go, caliper clipboard holder. So those have now become part of the model. Now you'll notice it's got big thick thing here that intersects with the model, so that may be a problem. I'll adjust that properly later. But then for the printing, and then we can actually go through the layers. I like the fact that you've got this hexagonal infill. Oh, look at that. I love watching those. Look at the tree-like support resolving there. That's gorgeous. And we're going right down to the bottom layers.
Dad, what are these meant for? Because we've got one 3D printed fully here, and we've got just a base and all of these thematics. I have no idea what to call them, but
okay. Well, this was a test print that I downloaded, and I've still not quite got it right. So this was supposed to be a print-in-place bearing. The idea being that you'd be able to turn the middle gear and the outer gear would go around it. So this one was too thick and they all stuck together.
This one is too bendy.
Too thin. There was only one wall. So I've got to kind of get those right, and it's me getting to know basically the Flash Finder print settings and how to adjust things. So this is a hybrid gear bearing, and what's tricky about this, and you can't quite see it in the model file, is you're supposed to print this without any top or bottom layers, and the result would be a set of gears that automatically mesh. Now if I say print with the defaults, now obviously the device is still printing, but if I slice it as it is, then the top and bottom layers are there. It's going to be filled with an infill. These are supposed to be in place gear bearings that mesh. Well, that's not what we've got. We've got this infill thing like so, with top and bottom layers. So let's see what happens if we mess with this. Go back, hit print, and we've got this dialogue here. So this is the basic dialogue. Now you've got some resolution options. We can set a raft, we can turn on a wall or a brim, we can change the supports, we can disable supports. We haven't got any for this particular. You can tell it what material you're going with. We're going to just be using basic PLA. And well, there's no choice of machine type, there's only detected the one at this point. We've got detail settings, more options. We can start to do some slightly interesting things. For this print, one shell, no solid layers, oops, and now you see this is where it's tricky because it is not letting us say 0. So we're in the basic configuration and this is not going to work. If we cancel this, we go to preferences, we can say, yeah, you know what, I kind of know what I want to do. So we go to expert mode, hit print, and we get a completely different dialogue. Now this dialogue, it's perhaps a little bit more intimidating. This is the full-on airplane controls as opposed to just a flight stick. And you're only going to want to use this if you're doing something more complicated. For most of my models, that basic setting with one of the middle detail settings is good enough. For this slightly weird model, I have slightly weird settings. Now, I actually have a profile called No Solids. So let's have a look what I've got in there. Okay, so I've got a shell count of 1. Now, I'm not going to mess with the speeds and the extrusion and cooling, but I only want one shell. So that's one outer layer. No infill. I mean, there's no point messing with this fill pattern, but you could do fill patterns as well. Vase mode. Let's hover it. That hover text is a bit dodgy. Yeah, it doesn't want to show me that. So vase mode is pretty much what I'm attempting to do with these settings. Supports, whether you print them, rafts, additions, okay, brims, walls, pre-extruding a little bit of material and then wiping it off somewhere. Cooling, again, I don't want to really play with this right now. And others. Now, it says pause at height. What I can't see how to do here, and this is a very unusual thing, maybe if you want to have multiple print styles for different layers, so maybe variable amounts of infill and similar things. But okay, so we've got infill 0, we've got vase mode, we've got perimeter 1. Now vase mode may already override this, but I can't see, so let's have a look. Click OK. Okay, it's going to make us save the GX again. Let's wait for it to render. So we have a completely different render here. There is no infill. There is this single wall. But you can see this is an utterly different kind of print. Well, I hope that's a good overview of how to mess with this software. So, one of the things that people were asking about was any problems. And one of the common problems with 3D printers is bed adhesion, i.e. sticking to the bed. Now, I had problems with bed adhesion, and I tried using special tapes, glues and everything. And actually, one of the last purchases I made was some different build surfaces. The new bed came with a new build surface. And there's only one time I've ever had a print not stick to it, which is my fault, because I had something that was printed upside down with no support, and these things, they fell over partway through the print, and I had to give up and abort the print and try again. I got things that fell over and mid-air spaghetti. Hurrah!
Hurrah, mid-air spaghetti.
So Helena, you know a little bit about this. Can you tell what's going on with the hammer, the block of wood, and the bed?
So my dad, let's give an example. He couldn't take this off the bed.
So what's the common problem with a new printer?
You cannot take it off the bed.
So the bed adhesion problem isn't that it won't stick, it's that it sticks so good that I can't get it off.
Woo!
And I was using this, which is, you know, the sharp palette knife or flat knife. And the problem I found was I was damaging the bottoms of prints, and it was getting increasingly dangerous trying to get them off. So I came up with a new solution. Cheers.
So we've got a block of wood. Let's quickly take that off. And my dad's literally went like this with a hammer, and then pew, went off.
Exactly. So I used the wood to protect everything from getting direct hammer blows, and I was using it almost like a lever. So I'd kind of place the print bed on the floor, and that detachable print bed makes it so much easier. And so this would be, say, stuck in the middle. I'd line up the piece of wood and then hit it like, basically hit it with the hammer like this to apply the blunt force trauma, and it would ping off after a couple of hits. And there's still something left to scrape, so can you see the bit of residue?
There's a tiny bit.
But that's why I have a hammer and a block of wood, and I might find a more elegant thing, but for now, that's working. Of course, not every print was perfect, and I did get definitely some spaghetti. And we've got a great comparison of the two printers. So I printed the rear section of the orbiter. Where are the engines? Are the engines over here somewhere?
Where are the engines?
We appear to have lost the engines for the orbiter.
In progress.
If you compare the orbiter rockets, the engines, then the difference between the two is really stark. So ignoring the colour of the PLA, because one is neutral and one is white, there is detail picked out on this that the old printer could never have done. And what's more, this new printer has better resolution, better speed, better temperature control. So it was able to do this better detail in far less time than the poorer detail took on the old printer. I mean, if you take a side-on section here, you can see the stringing. You can see that those top nozzles have basically just turned into blobs on the old printer, whereas actually on the new printer they're fairly well defined.
You can also see the colours different. One's neutral and one's
white. And we can put a neutral. I mean, we can put a white filament in the old printer and a neutral filament in the new printer.
It still would be the different.
But what you can also see if you look at these segments of the orbiter here, if you look at the quality, so it's quite hard to see with this camera, but the density of the layers on the new printer are far finer, and there's more problems with holes and pillowing. Now that's an intentional hole, and I've had to go and drill it out because it's poorly defined. Those holes are not intentional. And actually, if you compare, so here is the fuel tank, for the space shuttle.
And here's something else from
So that's the top of the SRB, or one of the SRB solid rocket boosters.
You can see the.
Go on.
We can see the difference because.
So if you look at the tops, the very pointy tops of them. So do you want to show the pointy tops, Elena? And you can see the difference in temperature control.
One is a blob and one is a pencil.
Frankly, the blob looks like a piece of ice cream. Terrible temperature control. I don't know if I should just reprint these again because they're so poor. They don't quite fit together because they're warped. And that's to do with the old printer. The warping came from two problems. This is the x-axis on the old printer. And the x-axis, I can make it wobble like that. The movement of the great big heavy hot end here would make it wobble. But also the y-axis had a little bit of wobble. Now I improved things when I stuck a belt tensioner, aka a piece of Lego, and I improved things by putting this to stop it catching, because these cables would drag and catch on the bed. So this was I made many improvements over its lifetime, but it was never going to compare with the Flashforge. So it leaves me with one other major issue, which is what to do with the old printer. And there were so many things wrong with it. I mean, what happened when we tried to leave it unattended? Can you remember any of the horrors?
Yeah, it didn't go kaboom, luckily.
Could have caught fire. I'm serious, by the way. I'll show you. But go on, what happened for you?
The tape.
Oh, the filament?
Yeah, the filament. It kept getting stuck next to it, and it was really annoying. I left it unattended watching TV, la 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 la, and it went wrong. Too long.
So it pulled the filament reel into the side of the printer, stopped the bed moving, made a horrible grating, the filament snapped. I mean, the print could not have been more badly botched by it. Whereas the Flashforge Finder has got, and you'll see this in the original filament, the original video, a filament cartridge with a roll. So it's not a cartridge you have to buy a new one. You put the roll of filament into it and you push that into the back, and it holds the filament nicely. It also, I think, gives it some protection from any humidity in the air, which is helpful, because humidity problems with filament, not great. What to do with it? I know that here's the heated bed cable, and it's slightly, although it's got this casing around it, it's still fraying. It catches down here. It's going to wear away. If that wears away, that could pose a serious fire risk or electrical hazard. Fan control's poor. The cables here for the extruder sometimes pull out, the hot end. The extruder feeding sometimes goes wrong. Now I've had to reprint this gear, but I also know I need to replace the PDFE tube. Here's the thing.
Dad,
yeah.
Question. If that piece broke,
it did.
Then how would you print it with this printer?
I was quite lucky in that I printed one as I could see it was cracking before it actually broke.
He's lucky. He's a lucky one.
Well, I saw it was going, so I printed it before it went. But it was a little bit of a, is it going to work? Over many years, I put lots of effort into maintaining and doing things with this printer, and I've never got results like I have from the Finder. And so I don't think it ever will, or if it did, it would be a significant rebuild. I want a printer to be able to build robots. I wanted a tool, and the Flashforge is a tool. This was a project. Power supply is good, although sometimes when the heaters were all running, it'd be overpowering to give up. I could give this to someone or sell this to someone, but I must admit, not in good conscience, knowing that it poses both a maintenance hassle and potentially a risk. I would not want to be responsible for this causing a fire. I've never trusted it unattended. I still wouldn't. The other one I can, because the other one can finish a print and turn itself off. And it's also not had any of these problems. The cables are all solid. I know there are people who have no 3D printer who love a 3D printer. This is not the printer for you. I mean, it cost me a few £100. It cost me more than a Flashforge Finder does these days. But it's just a little bit too dangerous. So I might say I would give away the Duet board, because I think the Duet board in it is quite good for someone who wants to upgrade a printer. I I'd probably repurpose some of the bearings and the motors. Leave comments below if you disagree, but it's potentially a dangerous device, okay? So it might be spare parts, which feels sad, but might be the only good way for this to end for that printer.
It has been a good time with him.
Well, it's been a learning experience, I'll give you that.
We had to put many things together to get it actually working, but it still wasn't as good as this one.
And I hope you've enjoyed that video and learned a bit about both my 3D printers, the old and the new.
So if you want a project for the new year, you can buy it. Learn robotics programming. So you can make a robot like my daddy's.
Absolutely. So in the book you can learn to program in Python using a Raspberry Pi and build a robot around it. It takes you through the making, the programming, choosing and coming up with the electronics parts and how you put them together. And it's got some fantastic photos and it's got board level illustrations, if I can find the right page.
It's creative. He came up with the idea of making a book robot.
A robot book.
A robot book with a robot, I guess.
Step-by-step instructions on building everything in there with the code, with the breadboard views on how things go together. So if you want to buy this book, it's Learn Robotics Programming by Danny Staple. It is from Pack Publishing and it is on Amazon. It can be found in the UK, I think, on Waterstones, on Foiled. I'm sure similar vendors in your country also have this book for sale. Building a robot for the new year. Awesome.
Yeah, it has lights and it can detect walls and it can detect different colours and I really like it. So
lines.
One more thing, go make stuff and be awesome.
Exactly. Bye.
Bye.